Yeah, you did. Good job. Yeah, see, when you put your mind to it, you can do it. I think you get distracted at home. I know. Everybody's doing. Well, I mean, have you done any of the missing work yet? Okay, good morning. Please join the Desmos. Put the link in the chat. We're going to look at inequalities again. This time do a little more interaction with the graphing. So you're going to be able to identify the numbers that were meeting the inequality statement, meaning you can plug the numbers in. And then you'll also be able to simplify them. So you find a single solution that's like x or less, x is less than something, or x is greater than something. And then you're going to be able to visualize the graphs that they represent. So let's go ahead and get started. There's a warm up. So see if you can, and here I'm giving you some options. You can actually go in and type out -2 times x, which is over here, 2 plus 4. -2 times 0 plus 4. See if any of these are going to be greater than 8. And then check the ones that are. Okay, so again, the link for the Desmos is in the chat. Okay, Jaden and Jaisha and Preston, Ayana, please start joining the Desmos. If it's still loading, I understand, but make sure you're starting to load that. Ayana and Faith, please join the Desmos. All right, so what I've told you here is that just we're kind of practicing plugging in our values of x into the inequality statement. So we plug in the x, so it's a -2 times whatever our x value is. And what we're trying to see is, okay, where do they start to get greater than 8? All right. So what are we noticing here? Sabira, what do you think are the values that are greater than 8 among our answers here?
12 and 20.
And so what are the x values that those are coming from?
What do you mean?
See over here, it says x. So I plug this x in to get 12. So which?
-4, -8.
Okay, -4, -8. Those are my values that are going to work for. So with inequalities, a lot of times we have more than one answer. We have a lot of answers. Like for example, on the next slide, you get to see there's going to be a lot of different answers. So you decide which one it is. Slide the point to where it works for the inequality. If you add 4 to your point, is it still less than 6? Okay, so for slide 2, it's -4, -8. And all I'm showing here is that if you plug in your x values, that's what's going to result in how to check for if it's greater than 8. You can't just say x greater than 8 because x greater than 8, it's this process. You got to put it into the process. Okay, Ramai, you got one more answer to pick. Mary Jane, please finish slide 2. All right, so slide 3, drag a dot for a possible solution. So drag this dot to where it possibly makes it work that there is a value on this dot that if you add 4 to it, it's still less than 6. So pick a point. So what's the point y'all have picked? What do you want to try first? What do you think, Ramaya? What's the point? What's an x value we can use?
0 will be an easy point.
Okay, that's right. 0, because 0 plus 4 is less than 6. So this one's almost too easy. So what we're going to do is we're going to try and use this kind of process. It might get a little more complicated the next few slides. And the first 2 slides are actually pretty simple. It may feel like, why are we doing all this work just to do something? It's just going to help you on the later slides. All right, Ayana, Jaden, Jaisha, you having issues joining the Desmos? You need the link? Faith, please join the Desmos. All right, really here's kind of the main part of our lesson today is we're going to practice looking at the graphs and looking at how we can come up with a simplified expression that's the same thing. So here, even though this phrase seems very basic, it's going to get a little more complicated. So let's just kind of practice the steps we would do. So I'm on slide 4. So if we go to slide 4 right now, so Ramaya and Jaden, please go to slide 4. And we just want to pick numbers less than 3. So numbers less than 3. And you can check to see, did you actually get numbers less than 3? Yes, you did. But the last part here is, did you actually write the phrase in an inequality? And that way you can write x less than 3. And it's going to actually show the graph. So really any number less than 3, you could even put negative 20, negative 4, negative 8. It's not going to graph negative 20 because it's not visible, but it is going to show up here. So with that same process, and if you're still working on slide 4, that's fine. But if you're done, go to slide 5. And instead of less than 3, it's greater than negative 5. So look for some values that are greater than negative 5. All right, Preston, Ayana, Jaisha, and Faith. I haven't heard anything. What's going on? Are you able to join the Desmos? Thank you. We're on slide 4. Ayana and Preston, I'm still waiting. Please join Desmos. So make sure at slide 4 you have all green and all green. Then go to slide 5. Okay, Charvez, Charlize, finish up slide 4. Okay, Jaisha, we're on slide 4. Okay, as I just sent you the link. All right, let's go to slide 5. So what are some numbers that are greater than negative 5? What are some numbers greater than negative 5? Mary Jane, what do you think?
4,
All right, 4. What else?
3,
3. All right, Faith, what's another one? greater than -5?
One.
Okay, 1, great. All right, so that works. What are some numbers not greater than -5? We're kind of check ourselves. We're going to see that these graph. What are some numbers that are not greater than -5? What do you think, Jaisha? What's the number like not greater than -5? And you guys can write in the chat.
What'd you say?
Okay, what's a number that's not greater than -5?
-7.
Okay, -7. So what I want to do here is kind of check and see. All right, -7 won't graph because it's not going to be part of this group. And there's no check mark. So can we see where the point would be? What about -5? Or -4? So -4 works. It's greater than -5. Why does -5 not work? Anyone know why -5 doesn't work?
Because it's equal to?
Right, it's equal to, so it's not greater than. It's no more than -5, so it's not greater than. Good. All right, so what is going to be the expression I write here for the inequality? It's going to be x something. Is it going to be greater than or less than?
What was the question?
What am I going to write down here for my solution of the graph? It's almost a little too simple. I want to write this as math terms. What do I write?
X greater than -5.
X greater than -5. Simply like that. So now it's going to graph this whole line. So everything that was plotted, it's still part of it, but it's saying it's actually everything in between here and the, greatest number you know. Okay, Jaden, we're on slide 5. Okay, Ramaya, please finish slide 5. Okay, Charvest, we're on slide 5. It's right here for you to do. Okay, Jaisha, please finish slide 5. Okay. Well, all right, let's go to slide 6, because this is really, that was pretty much just saying, okay, I already know it's x less than -5, or x is greater than -5. Here it's a little unclear. So there's 2 steps you can do. You can actually go ahead and solve it, or you can kind of pick out some points. So what's the number if I add 2 to it, it's still less than 5? What's the number if I add 2 to it, it's still less than 5? What do you think, Isaiah? Isaiah, you can join the Desmos now. So if I add x to x plus 2, what's the number that's still less than 5? What do you think, Chavez?
Repeat it again.
If I add x, what's the number I can add plus 2 and it's still less than 5?
2.
2. Good. So you can check that because it's going to be 4. What about the next number? 3. Why does 3 not get plotted?
Does it make 5?
Right. 5 is not less than 5. All right. So pick out some numbers that work.
1.
1,
-2.
-2,
-3.
-3, and one more.
-4.
Okay, great. So as we can see, they're all plotted down here to the left of what number? So they're all less than what number?
3.
Right, so x is less than 3. So that's one way you can do this. The other way is to go ahead and solve by isolating the variable. So if I have this, I'm going to subtract because I'm adding 2, subtract 2 from both sides, and then it's simply x less than 3. So that's one way to do it too. Okay, good. Does anyone need me to go back? Isaiah, can you finish slide? Let's do slide 6 later. All right, looking at slide 7, this one might be a little trickier. So let's go through this process. So what's a number I can subtract 1 and it's still greater than -3? What do you think, Ayana? If I have a number, I can subtract 1 from it, it's still greater than -3. X minus 1 greater than -3. Well, do you guys prefer? Do you like to solve it or do you want to actually try and test it first? Does anyone prefer testing it or do you want to just go ahead and solve it? All right, so let's solve it. X minus 1 greater than -3. What's my first step? What do I have to do, Isaiah? Anyone can help Isaiah? So what's the first step here? What do you think, Charlize? What's the first step I need to do here?
What's the question again? I'm sorry.
All right, so I'm solving X minus 1 is greater than -3. I want to get the X all by itself. So what's the first step I should do?
Subtract or add. Wait. Subtract 1 from each side or add 1 to each side.
All right, so let's think about it. It's one of those. It's one of those. That's right. We're already subtracting, so we want to do the inverse.
So you'll add 1 to each side.
Add 1 to each side. Thank you. Yep. So if I do that, what is X now greater than?
X is greater than -2.
-2. So let's try that. Now, what are some values that are greater than -2? It's basically anything inside this blue. So write your numbers, write some numbers here. What's the number that's greater than -2? All right, Jaden, what's the number that's greater than -2? All right, any positive number? So now that you know kind of what to do on these, try slide 8. Think about solving, think about plotting, whichever one you want to do first, and then your goal is to get that X value all by itself. So you're doing slide 8 now. I'm going to be right back. All right, Jaden, can you get to slide 7, please?
I'm already on slide 7.
You're on slide 7. Okay. Preston and Ayana, are you able to get to the Desmos?
No, I didn't see the link in the chat.
Okay. There it is. Preston, can you hear me?
Thank you.
Yep. Preston, we need you to join the Desmos. I just sent you the link. So if you can click on that, join it. All right. Thank you, everyone. I'm going to close the room. We'll go back to the main session. All right. Slide 7 should be finished. Okay, Ramaya, please do slide 7. Sabiros, please do slide 7. Charves, finish slide 7. All right. Anyone else need slide 7 up? All right, let's look at slide 8. This is where, what did you guys do? Did anyone start with solving it? Who solved it? Ian, did you solve it or did you start with plotting points? Oh, all right. Did anyone get started? All right, so what's the value that I could put in here? What's the possible value for X? Sabira, what's the possible value for X? Could be something we'll get wrong. It won't be
3.
true. Let's try 3. Okay, 3 works. So 2 times 3 is 6. Plus 3 is 9. Is 9 less than 15? Yes. So since we're less than, let's see if we can bump up against the limit by getting higher and higher. So what's the next highest number I can put in here?
4.
Okay, let's try 4. Does 4 work? 4 times 2 is 8 plus 3, 11 is less than 15. What's the next number I can put in?
5.
Okay, 5. 5 works. All right. So it looks like we're numbers that are going to be less than 5, but let's try What is the next number?
2.
2. Okay, 2 works. Can I try one that won't work? Where's it going to stop working?
6.
At 6. Okay, 6 doesn't work. And maybe 7 too. So it looks like we can have numbers that are less than something. So what are these numbers? They're less than what? So I'm less than, am I less than 5? Less than 6? Less than 7?
They're all less than 6.
X less than 6. So I'm just showing you like the approach to do this, where you can kind of test some numbers, see where it stops working. Count up by 1, count up by 1, count up by 1. If it's less than, you're counting up. If it's greater than, you're counting down. All right, well, let's also solve this. I think this is something people like to do because it's a little more of what we're learning in this class. So 2x plus 3 less than 15. All right, so here I have 2x plus 3 is less than 15. I want to get this 2x all by itself. What is the first thing I need to do?
Subtract 3 from each side.
Right, subtract 3 from both sides. Subtract 3 from both sides. So 2x less than, what's 15 minus 3? Jaisha, what's 15 minus 3?
It's 12.
12. So now, remember our answer is x is less than 6. So how did I get x is less than 6 from here? What's the next step here? What do you think, Isaiah?
Divide by.
Okay. Yeah. All right. What do you think, Isaiah? No answer. Okay. So we'll go back. Hayana, you said divide?
Divide 2 from each side.
Okay. 2x divided by 2 is less than 12 divided by 2. So that makes x, because this 2 over 2 makes it 1. So we have just a single x. What's 12 divided by 2?
6.
6. So that's how we can solve it. So you can kind of do it 2 ways. You can figure out where's my limit. Once I hit 6, it doesn't work. It's not true. So x is the number is less than 6, but I can also solve it algebraically. Okay, Ramai, we're on slide 8. Let's finish up slide 8. All right, so here's slide 8. If anyone, does anyone still need this up? Let's see. Sabira, let's get to work. And what I asked you to do now is go to slide 9, where you are basically going to graph on the number line the solution. Like here, x minus x is less than 6. Once you find that, it automatically graphs it for you. But now on slide 9 and 10, you will graph it. You'll draw it. It doesn't have to be pretty or perfect. Just make sure you kind of understand where's the limit, what direction is the line going to go. So I would recommend solving for x like we did here. You'll get a single inequality simplified statement and then graph it. Okay, Jaisha, please finish up slide 8. Good morning, Dr. Latchman.
Sorry, I'm so rude. Good morning, Mr. Guy. Good
Oh.
morning, students.
It's okay. All right. Yeah, let's go to slide 9. Anyone else need slide 8 up?
No.
Okay. So we're solving for this inequality in a sketchy representation of all possible solutions. So that's kind of what we're saying. Yes, normally we're used to saying x equals 3, x equals 2. Now we're saying there's a range of numbers. We want to know exactly where it starts and where it ends. It might end somewhere way off in the distance, but we'll know it goes in that direction. So let's think about x plus 1 greater than 3. So I think at this point, I want to see that you guys can solve this. So find a statement that just says x greater than something. And when you do that, graph it. Circle the starting point and sketch the direction it will go. So please get started on this. Good morning, Candarius. I've just sent you the link for the Desmos. Please join. Hi, Sarah. Please join the Desmos. I just sent you the link. Okay, Ian, show me that you know how to solve for x here. Solve for the x inequality. Sabiria, please show me you know how to solve. If you need help on what do we do, we did almost the exact same thing on slide 6. So here's slide 6. This is the process we're following. So if you need to go back to slide 6, do the exact same thing with different numbers. Okay, so Charves, what's the first thing I need to do? You need some help? What's the first thing we should do, Charves? Subtract. Okay, good. Subtract. Okay, Charlize, thanks. What did you say, Charves?
Let's say subtract.
Oh, I'm sorry. I see it in the chat. So Charlize has helped you out. So she said subtract. Do you know how much we got to subtract by?
1.
Right. So if we're doing a subtraction operation because we're already adding. We want to do the inverse. So then what do you think is going to end up here? What's our final answer?
1.
So we have 1 plus 1 minus 1. And then what's on this side over here? Okay, I think I heard something. What'd you say?
2 and 1.
2 and 1. Where? Tell me what's right.
2 on the right side, 1 on the left side.
So like this.
Yeah.
All right, but what happened here? Well, plus 1 minus 1. What's 1 minus 1?
2.
1 minus 1. Click this button on yours. I know that 1 plus 1 is 2, and we're used to kind of seeing 2 ones. That's a 2.
Oh, 0.
Okay, yeah, so 1 minus 1. I don't write plus 0. I could, but that's in math. We tend to try and say, if that doesn't make a difference, I don't want to write that. So we just get rid of that. Now, can I do anything else? Do I need to solve any further?
No.
Okay. So now we have to graph this. X greater than 2. So where should I go first? Which number should I kind of start with?
Positive.
Positive what?
Positive 2.
Okay. So I'm going to circle that. And then what direction are we going? To the right or to the left? Are we increasing? Numbers that are increasing or numbers that are decreasing? X is greater than 2.
Decrease.
So what's the number that's less than 2? So for decreasing, what are some numbers down here?
That
I think you said something, but I didn't quite hear it.
said negative numbers.
All right, so -2 or -1. Is -2 or -1, is that greater than 2?
No.
What's the number that's greater than 2?
4.
4. So here's an example of a number we can use. What we're trying to do is draw a line that's going to represent all numbers. What's another number greater than 2?
3. 5.
All right, so all these. So how do we represent all these with a graph? Like you just saw on the previous slides, what happens? It's not dots, not points.
Add.
Well, I guess I'm just graphing. We're not really doing any operations right now. What are you thinking? Like you're saying, add those numbers together? Let me just go back here. What do you see here? It's not points. When we're graphing it, what kind of shape is this? What do you see? I know we have some points, but we also have a line. Great, Jaisha. So we have to fill this in with a line. So we're not just saying it's the numbers on the dots, it's everything in between. So that means that we're representing all possible values greater than 2 on our number line with the line. Good. So next is slide 10. I want you to try slide 10. It's similar. You solve for x. There just is one extra step than what we did here. All right, so y'all finish up slide 9. When you're finished with slide 9, go to slide 10. You're solving. So you're going to end with a simplified inequality. But you may have to do one extra step to solve it. But I think you know how to do that. Okay, Jaden, let's get started on 9. Faith, please. Oh, I see. Good job, Faith. Go on to slide 10. So slide 10 is going to start very similar to how we did this. We're going to do something like this. Subtract the constant, but then you'll have to do one more step to solve for x. All right, slide 10. So go ahead and solve this. 2x plus 1 greater than 9. When you have a single statement, x greater than something, plot that here. So again, if you need help on how do I solve with this coefficient, there's a 2 in front of my x, go to slide 8. Look how we did it on slide 8. So slide 10, slide 8, it's a very similar inequality statement that we're simplifying. Okay, good job, Charves. Good job, Ian. So Mary Jane, what's the next step after you've done that? You've subtracted. Now what's that subtraction result in? I know I'm showing you slide 8, but you don't have to go to slide 8. You can use what I've shown you to solve for slide 10. Okay, Sabira, we're on slide 10. Jaden, we're on slide 10. Charlize, let's get started on slide 10. I've already shown you how to solve given a coefficient of 2. See if you can use that same practice. Okay, Faith, let's get started. Jaisha, let's get started. Ayana, let's get started. Slide 10. Show me you know how to do this. Anyone have a question or get stuck? Okay, Ayana, think about how you did slide 9. Please keep working on slide 10. All right, so what's the first step I need to do here?
Subtract one.
Right, subtract what? Did you say subtract 1? All right, so what's 9 minus 1?
8.
2x greater than 8. How do I get this 2 away? How do I get rid of that?
2x over 2.
2x over 2 is greater than 8 over 2. So what's my final response?
Is greater than 4.
X greater than 4. All right, good. So x greater than 4. And then plot it. So I have a, what's the first number I want to plot? Where should I circle my starting point? So the number here is 4. So I'm going to start at 4. The question is, will I be going decreasing to the left, increasing to the right? Numbers that are greater than 4, are they? I'm sorry, what?
Go to the right.
Go to the right, yeah. Increasing, greater than. Over here. Good. All right, slide 11. Think about what's already happening. We're already dividing, so we need to multiply. Okay, Sabira, Jaden, please finish slide 10. All right, so here I have x divided by 5. X divided by 5 is greater than 1. So what am I already doing with my x's and 5's? What's the operation there? X divided by 5. I'm already dividing. So what's the opposite? What's the inverse of a dividing?
Multiply.
So I want to multiply both sides by 5. So I do 5 times x over 5. It's greater than 1 times 5. So what happens over here is the 5's go away. 5 divided by 5, that's 1. So it's just a single 1. What's 1 times 5? What's 1 times 5? 1 times 5, y'all. What is it? What do you think it is, Mary Jane?
5.
5. Good. 5. So x is greater than 5. So graph that. X is greater than 5. So x is greater than 5, circle the 5, and then graph to the right numbers that are increasing. Okay, Jaden, Jaisha, Isaiah, Sabir, let's finish slide 11 that you see on the screen. All right, slide 12. So again, we did this on slide 10, same process, solve for x, and then graph it. All right, so what's the first thing we need to do here?
Subtract 2 from both sides.
Good. Subtract 2 from both sides. All right, and so what do I left with?
Would it be 2x over 2 is less than 15 over 2, I think?
2x over 2 less than 15.
Yes.
Think about what are we starting with 2x or what are we starting with here?
Oh, 3x.
So what do I need to do instead of 2?
Change it to 3.
All right, so change these to 3s. Oop. And what's 15 divided by 3?
Five.
5. So now I have x less than 5. I circle the 5. Now will I go left or right here? Will I decrease or increase?
Would it decrease because it's
Right.
less than?
It's right, less than. All these numbers are less than 5 over here. So when you're done with that, slide 13 is just a reminder that you can have less than or equal to or greater than or equal to. So on slides 14 and 15 and 16, it's very similar to what you've seen, but now think about less than or equal to or greater than or equal to. All right, so just think about less than or equal to or greater than or equal to. So now This one might be easier to solve. So if I write x plus 4 less than or equal to 8, if you want to get that symbol in Desmos, you got to type the less than and then equals right next to it. Less than and then push equals, and it'll just add it on there. So what's my first step?
Subtract 4 from both sides.
All right, subtract 4 from both sides. So x is what? Less than or equal to 8 minus 4, which is what?
4.
4. And you notice the difference here. It's a solid line, a solid dot. So this is closed. It means it's including 4. So if we put in here numbers less than or equal to 4, when we put in 4, it's actually still going to plot it. It says that's correct. All right, so we're on slide 14. Ian, Charves, Charlize, Shania, Jaden, Jaisha, please go to slide 14. All right, so please go to slide 15 when you're done with 14. And I think at this point you should be able to do 15. It's just now you're having a less than or greater than or equals to. So just add that equal sign inside the symbol. All right, so let's call that good for now, and make sure that if you have any missing work, I've sent you. If you have it, please work on that tomorrow. I will have tutorial tomorrow as well, so look out for that link, and have a great rest of your day. I'll see you Thursday.
See you Thursday.
See you Thursday.